Hello everyone. So let us continue with our discussion. In this lecture, my focus is to finish up with the five important stuff. Like number one is what is supervised learning. Basically, the learning divided into three parts: supervised, supervised, then unsupervised, supervised, unsupervised, and deep learning. Clear? These are the three learnings which we have to cover up, and apart from that, the second thing which we will study is the overfitted data and underfitting data. Now let us start with the supervised learning. Basically, supervised learning means like you have to teach a kid about maths with a textbook which has both the questions as well as answer. So the kid will see the problems and kid will see the solution, and he will make the inference out of it, and he will start learning. Similarly, now imagine that this machine learning program is a kid, and we are giving them and we are teaching that program how to recognize the cats in the picture. We will show them this bunch of photos, basically the questions, and we will tell them which one is the cat, basically the answer. So this is how the machine learning will learn. Supervised means everything is structured. Supervised means everything is structured. Your input and output data both are labeled. Your input data and output data both are labeled, means it will show you that these are the five pictures, and out of which this is not the cat, this is the cat, this is also the cat. Clear? So you can write down input and output data are labeled. Input and output data are labeled. Labeled means everything is written on it. Clear? So machine learning basically learns through these output which they are getting from the input. Clear? We call this as a supervised learning. But in case of unsupervised learning, input data are not labeled. Input data are not labeled means imagine that giving a kid a zigzag puzzle without the picture of the box. Clear? Now they have to figure out like how to put them together of their own. How to put them together of their own. Similarly, if I'll talk about the machine learning method, so we give a bunch of photos but don't tell anything about them. Means we have given 10 photos to the machine learning, like some are of cat, some are of tiger, some are of dog, and they all look similar. They all look similar. Now I have to tell the machine learning that this particular photo belongs to the kitchen. Clear? So this information is not there that this is the cat. So the machine itself understand that okay, this should be the cat, this should be the tiger, this should be the dog. So where the input data is not labeled. Clear? Write down input data are not labeled. Input data are not labeled. Input data are not labeled. Clear? And deep learning, basically it is just like a smart detective that can actually notice and piece together both the obvious and the hidden clues. Means whatever the information is hidden in the information in the photos, so they are basically very good in finding the patterns. They are very good in finding the patterns. So if I'll give you an example that it can take a look at a bunch of animal photos and not just spot the cat but even tell that what is the breed of that particular cat. Clear? So they will understand the data based on the patterns across the multiple layers of data. Clear? So these three types of learning: supervised, unsupervised, and deep learning. In supervised, input and output data both are labeled, and it is very easy for the robots to learn out of it. In unsupervised data, it is very difficult because the input data are not labeled. Means there are 10 pictures and we will not tell the model that this picture is the cat. So model itself have to learn. But deep learning is a very smart person. Okay, they can find out the patterns between the data. They can also identify the obvious and the hidden clues inside the photos. Clear? This is the one section about the learning. Three types of learning: supervised, unsupervised, and deep learning. Clear? Now this deep learning is basically a technique that uses the layers of neural networks. So you can write down these key points: neural networks. Neural networks. Basically this deep learning is using the concept of neural networks so that it can identify the patterns, and they can begin with some simple patterns, and then step by step it will become advanced so that they can identify even the complex patterns. Clear? And this deep learning may employ both supervised as well as the unsupervised learning. Clear? One example of the deep learning is I can give you the speech recognition. Speech recognition, you remember we used to say hey Siri, Alexa. So this is how they understand our speech, because they are designed with the AI. They are the robots who understand. If I'll say hey Siri, what is the weather today, what is the weather forecast tomorrow, or hey Siri, what is the score of India and Pakistan match, so they will give you all the information because they understand what we are saying. Clear? Now next we are coming towards the data. Over here we have overfitted, overfitting and underfitting. Overfitting and underfitting. So first of all, let us understand the overfitting, and basically I'll start with an example so that you will understand the whole of it rather than just going inside the textual term. So a student, suppose memorize the whole textbook word by word, but he did not understand the concept. Clear? So on the exam day, if questions are a bit different, definitely you are going to stuck because you have memorized it but you did not understand it. Clear? They know that exact book details but not the underlying ideas. We call this as an example of overfitting. Similarly, if I'll tell you about a program learned to recognize only the specific cat photos it was trained on. Suppose a new cat photo came in, my software will get confused. So this is an example of overthinking. See, I'm trying my best to make it very simple and easy to understand rather than making it very complex. Clear? Then we have underfitting. Underfitting means you have only read the book summary before the exam and you even miss the, you know only the basic but you don't know the details. Okay, you don't know the in-depth detail, you don't know the you don't have the enough knowledge, you just have the general knowledge and you miss the specifics. Clear? Similarly, a program can tell that there is an animal in the photo but unable to figure out whether it is a dog or a cat. Hopefully you are understanding the contextual understanding rather than going deep inside the term meaning. Means the example will make you understand that okay, what this is actually talking about. So over here we have the input and output data that matches exactly. Input and output data which matches exactly, means you have learned 10 questions. If the 10 questions will come in the exam, you will pass, but if something new will come in the exam, you will fail because your input and output data are matching exactly. Clear? And in case of underfitting, your machine actually fails to identify the actual patterns and relationship. Fails to identify actual patterns and relationship. Fails to identify actual patterns and relationships. And the last point to be covered in this lecture is the black box challenge. Black box challenge. You remember there is a black box in the aeroplanes which record all the conversations between the pilots, co-pilots, and how the engines are performing. Everything, means this black box will have all the information, and even after you will see that the flight got destroyed, but this black box are very safe and secured. So they have designed in such a way so that with the help of this black box they can identify that what is the reason of the plane crash. Clear? So sometimes how a machine learning program gets its answer is unclear. Means you don't know how you got the answer. Basically you got the answer but you don't know how you got the answer. So it's like putting the ingredients in the blender and you know what goes in, but what comes out, this is still a mystery. Means you take a small bowl and inside this you have put all the given inputs, but you don't know once you'll put everything inside what will be the outcome. Okay, so for that we are going to use the black box. Okay, if I'll give you an example, we know a program can identify the cats in the photos really well, but we are not exactly sure how it tells that it is going to be a particular cat, means of which breed. Clear? So this is a black box challenge. Okay, so I'm keeping this much in this lecture. We have covered up the 3 types of learning and 2 types of data, that is overfitting and underfitting, and along with that we have covered up the concept of black box. Okay, thank you.